Hi, this is ThroughPut. We debottleneck industrial supply chain operations with patented AI to make material flow. We're a Phase 3 contractor within the Air Force, working in the depots and on the Combat Command side in National Guard units. We're a Phase 2 status within Army Reserve, working with readiness operations, and we are TRL 89. We solve supply chain challenges for the top decision makers of an industrial organization. We've been profitable, have patents, and are recognized globally. The problem we solve is that, yes, material is not flowing globally, but what is the issue around it? Well, we've determined it's actually the software architecture that you're working with today. A lot of software today is built around what the supply chain planning unit needs, not what the entire value chain needs for inventory. And so you end up not having the full picture of inventory and not tying in systems that capture true demand, true lead times, and bottlenecks across the value chain. And because of this, you never have any impact in terms of ordering billions of dollars apart, but actually not leading to more aircraft readiness or equipment readiness or mobilization speedups. And that's because you're not optimizing the value chain, you're just optimizing what the supply chain function wants or sustainment or material command wants. And this is where a singular decision point comes in. Not only do we incorporate the entire value chain of where inventory sits, but we distribute those corrective actions, bring accountability and responsibilities across the entire organization, which is actually a 50 times faster way to actually improve the readiness issues. So think of this as the first system that looks at the bottlenecks, realizes, hey, we can't optimize all the nodes, but we can look at supply and demand disruptions and do it in a scalable way to address more and more of the needs for the warfighter. And we can do it at speed, scale, and other parameters that are needed, right? So we can look at more inventories in a week, we can look at more capacity, and we can actually react to market price and inventory to get the best deal as well for the warfighter. How this is different is we're not interested in building a system or repository, an ontology layer. What we're doing is we're mapping the data type to inventory, looking at the nodes of bottlenecks, using 1/100th of the compute to focus on floor on the bottleneck, using less engineers, and within weeks, we're actually physically validating if throughput is going up or not with huge significant financial impact. This is where we can actually enable billions of dollars of less inventory use, but an increase in equipment readiness. How it all works is pretty simple. We map the data and we quickly visualize the end-to-end supply chain from your suppliers all the way to your end customers. What the system's able to do then is effectively look at which suppliers we can continue to work with and give even more business to, and then which suppliers are not performing and we need to maybe substitute or figure out if they're going to deliver or not before the frog boils in the pot. We can see if it's an on-time issue, right? So that's FedEx versus UPS. If it's an info issue, which is a Honeywell versus Lockheed Martin, and an on-time info issue where you forgot to contract someone and you can take it up with a service member, right, to repair. What makes this system really powerful is inventory. Most inventory systems are not forward-looking. This system looks forward, similar to keeping a car on the road. This black line is the inventory you're spending, and the gray is your entire budget. There's often three sources of what's going to happen with inventory in the future. One is obviously with the sustainment side and material side, where they take historical data and say this is what's going to happen. The dotted blue line reflects what maintenance is seeing with the uptick of maintenance needs, and that's going to be a different forecast. And lastly, the plan that might be coming at a strategic level that nobody knows about yet, but is actually going to impact the inventory. So this system, at the speed of sync, is figuring out where that understock, overstocked is, and it's also predicting if you're going to be out of stock in the future or not, down to the individual item, right? What it's added to the ecosystem that the planning systems don't do today is it looks at this overstock, understock, out of stock situation and figures out what we can rebalance. Overstock is essentially all the dollars that we have tied up into warehouses that are not only slowing down the supply chain, but should be used elsewhere, right? So we can look at individual items at individual locations and move things around. Understock is our buglehorn to say, based off of everything in transit and how fast we're using it, right, and all the different parameters, we're guaranteed to run out. So I need these parts immediately, otherwise we're going to have downtime. And that's where rebalancing comes in. Rebalancing is, hey, even if we can't get external solutions, internally I can move stuff from areas where there's too much into areas where we're out of stock. And so think of this as the first system that's looking forward and saying, okay, what are my future deliveries? What are my future usage? And where are we going to end up? And how often do I need to order? It's looking at the inflows and outflows, optimizing around the bottlenecks. It's looking at the changing lead times and the service levels, and it's addressing those material shortages. This is applicable across the entire DoD, in fact, the US government. There's billions of dollars of inventory, about, in our estimates, $20 million that can be moved around using throughput internally without costing more to the taxpayer money. Thank you.